Hello everyone. In this video I'm going to go over the assignment for week 7 of the course. So if you look at the course schedule, week 7 we covered lists, sets, linked lists, stacks, queues, and decks, and the time complexities for common operations associated with these data structures. Now the assigned reading for this week is Miller and Raynham chapter 3, all of zyBooks chapter 2 participation activities, and the assignment for the week is micro assignment 4. Also, exam number 1 is likely due this week or near here. Check with the course schedule for your specific online course semester. MA4 is an exercise in queue analysis. The learning objectives for this assignment is to analyze stack and queue data structures for efficiency, implement a queue using 2 stacks, and compare and contrast different implementations of a queue abstract data type. Now, the prerequisites for this course, of course, write object-oriented Python code, write in Jupyter Notebook, and understand stacks and queues and their implementations. So this assignment does not have much of a data science context, but it is a good exercise in reviewing what you know about stacks and queues and taking your knowledge of those stacks and queues a little bit further, especially in terms of the efficiency of these operations associated with stacks and queues. So overview and requirements. For this assignment, you are going to download this Jupyter Notebook and answer the following questions. Your answer for a problem should be in a code cell immediately after the problem cell. We're going to explore the efficiency of 2 different queue implementations, and there will be some conceptual questions and some programming questions. So for conceptual questions, suppose you're given a strange computer that can only perform the following instructions, in addition to conditionals and loops. Create a stack, pop an item from a stack, and push an item onto the stack. Now, we want to answer the following questions about using this very strange computer that allows you to create stacks and push and pop to stacks. So the first question I'll describe and then I'll move on. Show how you can use these operations to implement a queue. So your queue operations, you need to create a queue, end queue, and dequeue. And I say a picture might help to explain your answer. And then I provide a picture that nearly gives you the answer. So take some time and look at this picture and think about how you could implement a queue using 2 stacks. And here is your stack interface you have to work with. Questions 2 and 3 refer to the time complexities of your queue implementation using stacks. And then for implementation, I want you to write a program that implements a queue using a standard list implementation and a queue using your solution to conceptual question number 1. And your stack should be using a standard list implementation. Now, I want you to generate a sequence of NQs and DQs to test out your 2 queue implementations. And you can test out your 2 queue implementation using our words.txt file just to get some input. Use timeit in order to time the 2 implementations and make sure that when you use timeit, you're timing your 2 implementations on the same test sequence. This is very important to make sure that you can even compare those 2 times to say one may be faster or slower than the other. Number 2 and 3 ask you to test your answers to conceptual questions above and write up your observations. The bonus here requires you to use linked lists and a deck for also comparison to your previous 2 implementations. So grading guidelines, of course, take a look at these, and submitting assignments. You are going to write up your solution in Jupyter Notebook. So as per usual, you'll turn in your zip file, your .ipynb source file, as well as an HTML file that is representative of your .ipynb Jupyter Notebook file. I'm also asking you to include words.txt and any other text files that you use in order to test your implementation. And the reason why I'm saying there might be some other TXT files to include is because of number 2 and 3, you may come up with some different test sequence or different data set you want to use in order to test your answers to conceptual questions numbers 2 and 3. All right, happy coding.